In this video, we will be solving equations involving indices by comparing indices. Recall that we can compare indices only when the bases are the same. In this case, both the bases are 5. So, we can compare the indices to get x equals 3. Now, in this example, you see that the bases are different, but notice that the base 3 on the left-hand side is a prime number, while 81 on the right-hand side is not a prime number. Can 81 be expressed in index form with base 3? Well, let's express 81 as a product of prime factors to find out. Can you see that the bases are the same now? In this case, 3. Thus, we can compare the indices to get x equals 4. Now, let's look at another example. Again, the bases are different. Recall that when the bases are the same, we can simplify the index forms and compare indices. So, let's try to get the bases to be the same. We know that 7 is a prime number, but both 49 and 343 are not. Thus, let's express 49 and 343 as a product of their prime factors. Replacing 49 with 7 squared and 343 with 7 cubed. Did you notice that the bases are the same now, which is 7? So, we can simplify the expression on the left side using these laws of indices. Now that the bases are same on both sides of the equation, we can compare the indices to get x equals 3. Now, let's try to apply the same concept to this example where both the bases are not prime numbers. In this case, how can we get the bases to be the same? Let's start by expressing them as products of their prime factors. Replacing 32 with 2 to the power of 5 and 8 with 2 cubed, we will have this. Applying this law of indices will give us 2 to the power of 5x equals 2 cubed. Can you see that the bases are the same now? In this case, 2. Thus, we can compare the indices to get 5x equals 3. And finally, we get x equals 3/5. Next, let's look at another example. Again, the bases are different, but we should try to make the bases the same. We know that 5 is a prime number, but both 25 and 625 are not. Thus, let's express 25 and 625 as a product of prime factors. Replacing 25 with 5 squared and 625 with 5 to the power of 4, we will have this. Applying these laws of indices and simplifying will give us this. Can you see that the bases are the same now? In this case, 5. Thus, we can compare their indices to get x equals 8. Finally, let's look at this example with different bases. Similarly, let's try to get the bases to be the same. We know that 5 is a prime number, but both 4 and 10 are not. Thus, let's express 4 and 10 as a product of prime factors. We write 4 as a product of prime factors to give us 2 times 2, which is 2 squared in index form. Similarly, we write 10 as a product of prime factors to give us 5 times 2, which is 5 to the power of 1 times 2 to the power of 1 in index form. Replacing 4 with 2 squared and 10 with 5 to the power of 1 times 2 to the power of 1, we will have this. Applying this law of indices will give us this. Can you see that we have bases 5 and 2 on both sides? First, we compare the indices for base 5 to get 2x equals 1. Hence, x equals half. Now, let's check if this value of x satisfies the equation formed by comparing the indices for base 2, which is 2x equals 1. We substitute x equals half into the equation, and we can see that the left-hand side equals right-hand side. This means that the solution for x equals half also satisfies the equation, and this is how we can check the solution. In general, when solving equations involving indices, by comparing indices, we express the bases as product of prime factors. Simplify by applying the laws of indices, and compare the indices where the bases are the same to find the unknown in the equation.